Hey everyone, Mr. H here. Going to continue with 7.2 verifying identities. As you can see, I'm at the bottom of page 3 here. We already did that problem, but I rewrote it. I rewrite all the notes and they're available to you as a reminder in the modules notes. I know sometimes I get a little sloppy in the videos, so I try to redo them, write them nicer. I also go back through the problems, make sure I didn't make any mistakes or try to catch any mistakes I made. So hopefully that helps. Not a bad idea for you too, if you want to rewrite your notes. It's always a good strategy. Anyway, let's continue. Let's go on to number 6. So here we have this one. Let's see if we can change that left side into the right side somehow, some way. The first thing I'm looking at is a quantity squared. I feel like I want to multiply that out to see what develops. Sometimes on these, you don't really know where to start. I know they're challenging because each problem is unique and different than the rest. So sometimes you just got to try something and hope it goes somewhere. If not, you start over. Oftentimes there's more than one way to do it. So you might end up finding a way that maybe I didn't do. So let's try it out. Okay, we're going to multiply this out. So that left side, I'm going to write it as secant tangent times secant tangent minus tangent. And then I'm going to FOIL this. So this is secant squared. It's the first. The outside is secant tangent. So minus secant tangent. The inside is a tangent secant. I guess that's the same thing, right? And then, oops, that's a theta, alpha. And then the last is a positive tangent squared, negative times negative, positive. Okay, so there's foiling it out. And then, let's see. I do notice there's a secant squared and a tangent squared. There's some identities there. See, there's one way maybe using some identities, but since we're after something that has sine in it, you might want to, at this stage, just turn everything into sines and cosines. Right? So I would use that strategy here. So this is 1 over cosine squared. I actually have 2 of these that are the same. So I'm just going to write this as 2 secant tangent, and then I'll change those in a minute. And then tangent is sine squared over cosine squared, tangent squared, sine squared over cosine squared. Okay, so that's something. I don't know if it's getting any simpler. A secant is 1 over cosine, and a tangent is sine over cosine. Okay, and so now I've got everything in terms of sines and cosines. All right. Oh, look at this right here. That's kind of nice because that's a cosine squared. And so they all have cosine squared in the denominator. Sorry, I'm going to invade the space of this one for a little while. So this is going to be 1 over cosine squared minus 2 sine alpha over cosine squared right there, plus sine squared over cosine squared. Okay. Now I can combine it all as the one fraction. And that feels like we're getting somewhere. I guess this is going to take the whole page. So I didn't leave enough room, but that's okay. Okay, what's next? That top can factor, right? So if you're skillful in factoring, the first terms have to be 1 and the last terms have to be sine theta, right? Because 1 times 1 is 1. Sine theta times theta would give you that sine squared. And then these would both have to be minus. Okay. Also, cosine squared, let's get that in terms of sine. It's 1 minus sine squared. Okay. We're almost there. That 1 minus sine squared factors. So that's going to be 1 minus sine, 1 plus sine. That's that difference of two squares. Right. Factors into that. And then now we can remove a common factor. And we've got our right side, 1 minus sine alpha over 1 plus sine alpha. Okay, so that's how that one works. It's a little lengthy there. That one was started way up there, but we did get the right thing. And on that one, I didn't write down the justifications. I talked through them. When I rewrite the notes, I will definitely write them down. But revisiting this one, the first step here was to multiply it out, FOIL. Then we turned everything into sines and cosines and combined like terms in the middle. Then we, on these two steps, did some algebra, added all of the terms together using a common denominator. Then we factored the numerator, and we factored the denominator and canceled or removed a like factor for the final answer. Okay. All right. Let's try another one. I'm going to erase that problem so I have room for the next one. Okay, so now it's gone, but you can always rewind and check it out or check out the completed notes. It'll look better there. How about this one? Ooh, okay, so we got secants, gonna change them into cosines. Okay, I think we got this. So let's start with that left side. I'll blow it up a little bit so I can use more space. The secant, I'm gonna write as 1 over cosine. Use that reciprocal identity. All right, so I'm just working only with that left side, not with the right. And then I'm going to do some combining within each numerator and denominator. So up here, I'm going to multiply by cosine over cosine, and here as well, cosine over cosine. Now, getting a common denominator within each numerator and denominator of the big problem, and then combining them. So this is going to look like the big fraction bar. The top is going to be 1 plus cosine all over cosine. Which is promising because a 1 plus cosine pops out, and that's what we're trying to get to. The bottom is 1 minus cosine all over cosine. Okay, so that's awesome. Now I'm going to invert and multiply, right? So the top is going to stay the same, 1 plus cosine over cosine, and I'm going to multiply by the reciprocal of the denominator. Right. And voila, the cosines cancel, and I've got what I'm supposed to get, 1 plus cosine over 1 minus cosine, write it as one fraction. That looks good. Okay, so the steps I took there is I first applied a reciprocal identity, and then in the numerator I got a common denominator and added it to get one term, and in the denominator down here I did the same thing, added to get one term. Then I multiplied by the reciprocal, removed a like factor to get the final answer. Okay, how about this one? If you have, these look equally complicated, both left and right, but if there's a plus or a minus, there's probably more that you can do. So I'm going to start on the left side, and I'm going to, let's get reciprocal identities going. That's 1 over cosine squared plus 1 over sine squared. Okay, and I need to add with a common denominator, so I always like orange for that for some reason. Okay, so nope, I don't want to multiply that by sine. I want to multiply by cosine. So multiply this side by cosine on top and bottom. And then on the other side, I need the sine, top and bottom. Now you can see that the denominator matches. It's sine squared, cosine squared. So I should be able to write this all as one fraction with a denominator of sine squared, cosine squared. And the top is sine squared times 1 plus 1 times cosine squared. So times 1 can drop out. It's just sine squared plus cosine squared. Okay. So that's good. We have all one fraction now. Now look what popped out, sine squared plus cosine squared. If you know your Pythagorean identities, that pops out at you because that just equals 1. So I can replace that whole top with 1. All right. Cool. And now I can separate this out into 2 terms. 1 over sine squared times 1 over cosine squared. That's the same thing. And then that reciprocal identity, that's cosecant, and that's secant. And that's what we're after, kinda. I guess I can flip them around to make it look exactly the same. Multiplication is commutative, and we've got it. Okay, so the steps I took there, I got a common denominator and combined them to one term. That was that case. Here, that's combined. I then used the Pythagorean identity and replaced that top with 1. Sine squared plus cosine squared equals 1. Once I get to this point, I can separate it out because that's multiplication. I couldn't do that with addition, right? But multiplication, you can separate it out. That is the same. And then now I used reciprocal identities to get the final answer. Okay, these are fun, right? Oh man, look at this one. Okay, let's try it out. So that left side, there's a lot going on. But I noticed that every term has cosecant squared theta. My instinct then is to factor that out. So I'm going to take out a cosecant squared. If I factor that out, just like algebra, that first term is just 1 that's left. The middle term, you have 2 cosine theta. And the last term, you'd have a cosine squared. Okay. Now this factors. That's 1 minus cosine theta, 1 minus cosine theta. Okay. Well, we got a 1 minus cosine theta. That's promising. Cosecant squared is 1 over sine squared. All right, so I can use a reciprocal identity. And then sine squared, a Pythagorean identity is 1 minus cosine squared. Okay. And as we've seen before, you can actually factor those into 2. So that's 1 minus cosine, 1 plus cosine, and that factors algebraically. Okay. All right, now we can maybe remove something. Yeah, 1 minus cosine would be removed, and then when the dust settles, I have a 1 minus cosine up top and a 1 plus cosine at the bottom. And that's true. Okay, so the steps I took there. Factor out the cosecant squared. Factor what's left inside the parentheses. Reciprocal identity, 1 over sine squared. Pythagorean identity, sine squared is equal to 1 minus cosine squared. Factor that 1 minus cosine squared, and then remove a common factor. Okay, one more. Let's try one where we're going to work with each side because they both look complex, and then see if we can simplify each one separately down to a common thing. Okay, so let's work with the left side first. So over here, we're going to do the left side. Let's see. I would start doing everything in terms of sines and cosines. So we have cosine over secant, which is 1 over cosine. Tangent is sine over cosine. Sine is just sine, and then cosine. Okay. So there I can see that those cosines are going to cancel. And then this piece, this first piece, I'm going to multiply by the reciprocal. Right. And then here I have sine times sine, that's sine squared. Okay, so I multiply by the reciprocal. Cosine times cosine is cosine squared. And then if you know your Pythagorean identities, this is awesome because that just equals 1. Okay, so notice here, I just work with the left side and I was able to simplify it all the way down to 1. Okay. Can we do that with the other side? Well, think about cosecant squared minus cotangent squared. That by a Pythagorean identity is equal to 1. If you wanted to show a step or two, I mean, the cosecant squared is the same as 1 plus cotangent. Right, so I can replace cosecant squared with 1 plus cotangent by the Pythagorean identity. And then the cotangent minus cotangent is gone, and you're just left with 1. Okay, so that's the right side. So I independently work with the left and the right, simplify them down to the common third result. And those are the same, so this verifies the identity to be true. Okay, that's it. Practice with these. That's the best way to do them. You just got to keep doing lots of them and try them out. And hopefully you get better. Okay, that's it for now. I'll talk to you later.